Hello and welcome. This is a presentation on open source firewalls and by Justin, Kim, Mitch, and Keith. Open source is not simply freeware. It is software for which the original source code is made freely available and may be redistributed and modified. So we had to find a firewall that was more than the free offering of a commercial product. Firewalls are also not all created equal. We had to choose from host-based firewalls, which only protects a single device, or a network firewall, which protects everything behind it on the network. It typically is installed at the edge of the network. So we took a look at pfSense, which is a free program. It is very widely used, has a huge community of support. It's lightweight. It doesn't take up too much room on the system resources. It has enterprise support and a lot of advanced features like layer 7 inspection. It does take a lot of installation. It's very, very hands-on to install it, and there's a lot to learn for it.
The second firewall we looked at was IPFire. This is open source also. Pros are it's free, of course. Has great add-on package support for additional functions. It's lightweight and great web GUI. Cons are the IP version 6 has to be enabled. It's not functional out of the box, and 64-bit support is not as good as others. The third one we looked at was Untangle. The pros, it has a great GUI and it can back up configuration in the cloud nightly. Great community support, good product documentation, and enterprise support is available. The cons are it's heavier system requirements leading to slower boot times, has stricter hardware compatibility than others, and a lot of the features are stuck behind a paywall. You have to pay for it. Our recommendation is pfSense. It's most widely used. Available today is free for most users, but has a lot of support for even larger enterprises. While the initial setup is all done from a terminal, most of the setup can be done from a web GUI. The pfSense requires less system resources and allows it to run on a wide range of available hardware. Due to the wide audience, pfSense is a great community willing to help with any issues you might come across, just like many of the open source programs. Documentation is easy, and the advanced features are included in the base installation.
pfSense can be a really attractive alternative. As we said, you can run on a very wide range of computing platforms, and for free you get software that provides many features that are otherwise enjoyed by enterprise-level installations. For example, concurrent IPv4 and IPv6, as the world transitions over to IPv6, it may not be practical for a small business to completely throw away their old business with their old equipment and just jump on the IPv6 bandwagon. We've also got support for multiple operating systems and failover in your VPNs. And so if you've got clients that are out on the road, one guy's got a Mac, the other one's got a Linux system running on his laptop, and still another is Windows. These could be very handy to have. And other features that we've listed here, but there's a whole lot more that's available, and that's probably the number one reason for choosing pfSense, because it offers many enterprise level features that you simply aren't going to get with lesser products that you'll pay drastically more money for. And again, for a relatively nominal charge compared to the cost you'll see in another slide that go with some commercial products, you can get professional support that'll help you enable even more features. So let's talk about pricing a little bit. Technically, pfSense, it's an enabled device. It is a perimeter security device. Now that's what's starting to happen, also known as Unified Threat Management Appliance, where the router on the edge of your network also functions as a firewall and does a whole lot more things than they've done in the past. Comparable commercial solutions start at $500. I'm speaking of the Meraki MX64. It's a $500 firewall, but you've got yearly licensing costs that you have to pay. And then as you move up, things get dramatically more expensive. The Cisco Firepower 2110, which is at the bottom of that particular line, his list price is nearly $11,000. And then for the SmartNet Solution Support Service Agreement, for a 3-year discount, it's going to cost you nearly $8,000. And then one thing about these commercial products, every scalability becomes a problem. Every time you scale up, you literally retire the old equipment and buy new. And so, for example, if you went up the Cisco line, the Firepower 7125 is a $300,000 device, and right up there at the top, the 8360 is $3.1 million. Now, you probably wouldn't use a PFSense, to replace the Cisco 7125 or 8360. But with robust equipment, you probably could. The biggest difference there is the actual equipment behind on those high-end firewalls in the first place. So coming back to reality, for small companies, PFSense should seriously be considered. As you scale up, it'll stay with you, and you can just incrementally increase your capacity as you move forward, and it'll give you the features that you need in order to protect your investments, protect your business, and all that you're trying to do. And by the way, that service agreement for that Cisco 8360 is over $140,000 each year. So why would you bother with PFSense at home? You could literally take an old computer that you've long since retired, throw in a $10 network card, and suddenly you could have some of these great features in your home to protect your loved ones and all that you care about. And if you'd rather not go through the hassle, a company called Netgate will sell you a PFSense-based network appliance for a mere $149. Now, does your ISP charge you for data overages? In my side of the world, Cox does. And so it's kind of important that we make sure we don't run on top of that, otherwise we'll get additional charges. You can use PFSense to tell you how much you used this month, but it'll also tell you who used it and what they were doing with it. Have you ever tried to set the firewall on your smart TV? How about the security settings on your smart thermostat? You can protect everything on your network in far greater measure by using PFSense on a firewall at the front end of your home network. And so now I'm going to turn the time over to Justin, and he's going to walk us through a few of the features.
As you can see from our slides before, we recommend PFSense as the open source firewall of choice. The installation of PFSense can take quite a bit. However, because of the great community that's around it, finding instructions on how to install it on almost any platform is quite easy. Once you've gone through that process, you'll notice that everything on the machine itself is in command line. During the installation process, you're required to set up at least 2 adapters, one WAN, one LAN port, the IP addresses and subnet masks for each. Thankfully, however, most all of the setup can be done from a web GUI from a separate system, as you'll see now. To access the web GUI from another system, you need to be on the same network. You'll go to the IP address specified on the LAN port. In this case, it's 192.168.55.1. On the home page of PFSense, you'll see many pieces of information about the platform that PFSense is running on. Including in this case, you can see that it's running on a virtual machine, as our BIOS is a VirtualBox BIOS. The release version, the build of the PFSense that's running, including hardware for the system that it's running on as well. You'll see the current status of the 2 ports, the WAN and the LAN ports. But what we're interested in is the firewall functions of PFSense. All those functions are listed here under firewall. So let's start with the rules. All filtering in PFSense for the firewall is done through a rules platform. Those rules are then split up into the adapters that they belong to. As you can see here at the top, we have the WAN and the LAN adapters, as well as this third option for floating. Floating rules are rules that will be applied to any adapter on the system itself. You can see there are currently no floating rules defined. So let's start with the WAN. By default, there are two rules set up for the WAN port: block private networks and block bogon networks. By default, any network activity that initiates from the WAN will be blocked unless it reaches a rule that specifies it to be let through. These two rules block all network traffic by default. Block bogon networks blocks any network originating from an IP address that's not currently assigned to our organization. Block private networks blocks everything else. So we go over to the LAN port, you'll see that there's three rules. In contrast to the WAN port, any traffic that originates on the LAN will automatically be let through. You'll see that there's two of those rules, one's for IPv4, one's for IPv6, are designed to let that traffic through. The third rule that you'll see is this anti-lockout rule. As you'll notice, it cannot be moved or deleted or changed in any way. This rule is completely designed to prevent the user from setting up a firewall rule that will prevent you from accessing the web GUI. Because of the way that pfSense handles rules, each rule is applied top to bottom. This anti-lockout rule is always going to be at the top. Therefore, it will always be applied first, preventing any rules following it from overriding it. Here at the bottom, you can delete, save, or add new rules. This button would add rules at the bottom of the list, so it'll be applied last, and this button will add rules at the top of the list. In this case, it'd be between the anti-lockout rule and this IPv4 rule. As we go to add rules, we have to select the action that we want that rule to perform. We want it to pass the packets through, block them, or reject them. By default, we want this rule to be enabled. Select the interface that we want and the address family. So right now, IPv4, as all of our internal IP addressing will be IPv4. From there, we select our protocol, and we want to make sure our protocol is as specific as we possibly can make it. So for now, we'll just leave that on TCP. From there, we actually have to give the rule something to match against, a source or a destination. Where is that packet coming from, or where is it going to? Based on this, the pfSense will inspect the packet and determine if this rule applies. We need to give each rule a description, as when you come back later, you might not understand why you created a certain rule. We can then save those rules for later. pfSense Firewall has many other features to it. For example, traffic shaping is for quality of service. You can, on each individual interface, determine what the current bandwidth should be limited to. In addition to the regular rules and the quality of service, you can also add schedule for these rules. In a sense, you're saying that a rule is only valid during certain days or certain times of the day. If you had this rule set up in your own home, say you didn't want a certain gaming website for your kids to be available during the day, you could come in here and give the rule a name, give the schedule a name, pick when you want that rule to be applied and what times you want that to be applied, and then configure. This could be used for many purposes, from work sites blocking certain types of applications during peak hours to improve performance of the network, to the example I gave the first time of preventing your kids from gaming when they should be doing schoolwork. And pfSense as a platform is extremely powerful, with many more features that are available in addition to these, from the ability to create VPN tunnels between 2 points to managing the network in a large corporate environment. We hope that this brief look at open source firewalls and this brief walkthrough of what pfSense can do was helpful for you. Thank you for watching.